Stadium tour planning and management using genetic algorithm and dynamic programming. Abstract the happening to web and m-wording of d.wnl ding musi, the musi. Businesses nfr.enting. .re. ri.usde.re.se and .d sales which used membership-based revenue stream.f musi. Industry. The sales have endured to great extent be use of illicit d.wnlds and membership-based musi. .administered.ti.ns like estify, g.nn. nds. n. Recently, the .rim.rewells.ring.fs.l.re.f musi. Industry is t.uring. Buse.f, rl.gisty.s, blunder.nd, rr.ute.isi.ns numer.us.ren. Visitsniggle.tt. r.do.e benefit. This t.skm.kes.ren. Visiting. g.ing.gre.t.r.dur.nd.s.rtil.s.n.bly.bexe.ted. The eminent.f finding the m.st brief w.y will.hd.w and the su.erfelu.ussttht.reused in trns routing the st.ge equi.s just.s the t.uring singer b.nd individualidu.ls, bku. Retusts, reinf.r.emint.retusts, f.und.ti.nv, lists.nd. The required stffs. This.r.je.th.sv.ri.usm.duls.tht will hell. In betterment.fl.gisty.s side.f the t.ur. tgener.tesh rootist r.ut insisting.ll required.itis genity. .lg rhythm.nd.me. .r.garming, r, h is used. This.r.blem n.enter.tes.ntr velling s.lesson.n.r.blem. Keywords Traveling Salesman Problem, Genetic Algorithm, Dynamic Programming, Logistics, NP Hard. Introduction. This section is aimed at introducing the traveling salesman problem which we have used later to address and tackle the issues faced by the music industry in tour planning. We have also briefly introduced the two approaches that we have used for finding the optimal route. These approaches are genetic algorithms and dynamic programming. We have elaborated on the algorithm in the proposed methodology section. A traveling salesman problem. TSP, traveling salesman problem, is a classical NP-hard problem in the field of computer science and operations research and combinatorial optimization. The problem is to find the shortest path among the given cities, such that all cities are covered once in the path and return to the starting city. This problem can be applied to solve many real-world problems. Taking the instance of a courier company, they have to deliver a number of packages throughout the city. They can use TSP problem to find most optimal route, thus saving time and fuel. Also, while planning a route for drone flight, choosing an optimal route through the specified waypoints can not only reduce time but may also extend the area that could be covered in every single flight. There can be other parameters needing optimization in each of those problems, but at the core, each can be viewed as solving a modification of TSP. It's an NP-hard problem in computational optimization important in Mitanshi Kshatriya School of Computer Science and Engineering, Vellore Institute of Technology, Vellore, India. Research and Theoretical Technology. The amount of time required to solve this problem grows exponentially with the number of cities or inputs being increased. TSP is expressed as follows. Let 1, 2, up to n be the marks of the n urban communities and c equals CAB be an nxn cost lattice where each entry of the matrix represents the expense of heading out from the city A to B. In TSP, we need to find an optimal route such that each city is visited only once and the last city visited should be the originating city. The absolute cost of a route is given by A, n, equals, I equals 1 to n1. AA plus 1 plus 1, 1. This paper introduces two ways to solve T-spoon based on genetic algorithm and dynamic programming approach. B. Genetic algorithm. Genety. .lg rhythms, resented by J.H.LLND, 1975. Rem.tiv.ted frm the d.ruin.dvn.emint high thesis, in the ule devilment, the best.ele, whi.h.rem.re.justed there entity.n, and.etl.stf.r quite. While, .n the .there h.nd, the .ele, whi.h.re.n.t fits t there entity.n, v.nish with the entry.f.guess. In this w.y, it's .hrm.s.me.nd. .rer wellness, itytb.h.r. Tierized t. ses.ele every.ers.n. inity.lly, g. m.rises t. rbiter.riley.re.teintr.do.t.re, ule.ttht int, genity. er.t.rs, seal.ti.n, .r.ss ver, mut.ti.n, inside determined.r.b.abilities, .re, lid t deliver.n. their gener.ti.n tht considered best thn its .rev.us versi.ns. The traveling salesman problem is considered as an optimization problem. It can be solved using a genetic algorithm since genetic algorithm is used for solving optimization problems. See dynamic programming. Dynamic.r.garming is useful computer programming method as well as am.them.til for solving optimization problems. It can be used to determine an optimal second.e.f interrel.ted.isi.ns. The main idea followed in this meth.ds, location is dividing.f. .rs int. Several stages. After whi.h.n optimal result is chosen f.r every st.ge. Dynamic programming is applied to problems recursive in nature. To save the computation cost of repeating recursive calls, the recursive calls are stored. If the recursive call's value is in store, that value can be used right away. There. Retw. Fund.ment.l, r, he's f.r solving ts, .reise.nd estim.ted. .reise.regener.llyf.undade.nbrn.h.ndb.und, dyn.me. .r.garming, integer a lid m.them.ti.s. All of them can give optimal solutions for TSP. However, the methods above give exponential time complexity, i.e. the time taken by the methods increases exponentially with increasing time. The time complexity for the dyn.me. .r.garming method is calculated to be n 2.2n. Thus, while solving TSP with dynamic programming, it can at best handle 40 to 60 cities or data points using branch and bound strategy. It might be able to fathom up to 200 cities or data points. 2. Literature review. In the literature, researchers the joining of genetic calculations, GAS, with hierarchical data sets to take care of the combinatorial issue in asset enhancement and the board. 1. The authors of the paper have proposed using 2 levels of knowledge, procedural and declarative. It will help in addressing the issues of combinational optimization as well as numerical functions. 2. The authors of this paper showed genetic algorithms can be integrated in any form of DSS or decision support system to ensure economical use of resources. TS is det.s disveering. h.nge.fnurb.n.res, whi.hh.s the b.seexens. This issue is widely knwn as an nh.rd problem 2, 4, 5. numer.usl.ol.ti.nsh.ve.bin.r, said tt cle this issue 2, 3, 4, 5, 7, 10, 11, 12, 14, 15, 17. There. Retw. Fund.ment.l.meth.d.l.gsf.r.dressing ts, ex. t.nd, r.zim.te. Definite meth.d.l.gees.retie.illyf.undade.ndyne.me. .r.garming, brn.h.ndb.und, wh.le numberline.r.r.garming. nd.llg.ve the ide.l.n swears f.rts. However, it must be noted that the l.ol.ti.ns which are using these meth.d.l.gesh.ve rem.rk.ble runningtime.sm held.ndrmkr2 int.ut in their research work. dyn.me.r.garming t.kes, n 2.2n, running time. Thus, while solving TSP with dynamic programming, it can at best handle 40 to 60 cities or data points using branch and bound strategy. It might be able to fathom up to 200 cities or data points. 3. The authors of this paper have used tree decomposition with dynamic programming to further optimize the solution for TSP. Let there be trvelaying s.lesum.n.r.blem, ts, the solution for it is t.urh in gr. hg. An operation k-m.ve will rem.ve k edges frmh.nd then proceed to .dd k edges.fgs is to form new t.ur namely h. The well-known kt heuristy. F.RTS uses the K-moves method. It firstly finds L minima by st routing frm.n.rbitr.ret.urh.nd. Subsequently im.r.ving it using second.e.fkm.ves v.ri.usm.utti.n.l testing shwed tht new g hrm.s.me r h result in smaller ser.hs e further m.re mu.h.f the time delivers.refer.ble.rr.njments.ver.st.rdures for the MTS is simul.r problem t the popular np hard tr velaying s.lay.ers.n.r.blem ts with the did on strain theh city can be visited by .newyork.ne from the s.lay team. Review.us studies investig.ted s.living the MTS with Genity. .lg rhythms g.s using stnd.rdts. hrm.s.mes.nder.t.rs. The above paper presents a new chromosome for GA and then proceeds to compare its performance in accordance with time and space complexities. 3. Proposed methodology. Stadium Tour Management Framework is an attempt to defeat the logistics issue confronted while leading an arena visit. It will decrease the odds of scattering of any stage hardware as a database can be utilized to cross-check if each gear is available or not. Our venture would be a great guide to the tour manager as he/she will have all the data, pretty much every one of the necessities of the visit. All the data can be seen by the administrator. The Stadium Tour Management Framework has 4 modules. All the modules have all common features of what is expected in a database management system like create, read, update, and delete along with some additional features. A database. I Stadium database. 3 staff database. B algorithms used. Generating the shortest route covering all cities is equivalent to traveling salesman problem. For this 2 approaches have been used. 1 genetic algorithm. 2 dynamic programming. The distance matrix is generated with the help of a table containing the distance of one city to other. Distance is 0 for the same city. Genetic algorithm. I creating distance matrix. It is a 2D array where the entry at I, j represents the distance from the ith city to the jth city. 2. Creating population. Population is a collection of possible routes. 3. Determining the fitness of the population. 4. Select the mating pool. V. Breed/ordered crossover. 6. Mutate. 7. Repeat the above process until the required number of iterations is reached. We are using 2000, 4000, 5000 iterations. Dynamic programming. For testing and results, we used D. NDG. NTR.STT. RE-TE minimum S-ning TH. The L.ul.ti.ns were, lid.fdistn.em.tricks.f8.itas. Genity. .lg rhythm seem t disver gre.t.n swears f.r the tr.velaying s.lesum.n.r.blem. .nywl.ysrti.ol.rly.nh.w it is nded.ndwhi.h.r.ssver.nd.ti.nstr.tages.reutilized. Likewise, it d.es not h.ve.netim.ls.ludi.n. h.weaver, it.r.vides with best sybil s.ludi.n. dyn.me.r.garming, r, h is rel.tivolisim.let. Yet it requires s.me investment when the .m.unt.fdt in .remonstity.n.lly. Beginning.ity must be indeted in its day. It is extensive f.rmem.re.swell.s time. The qulidi.fs.ludi.n.ns.n the day. Comparison of algorithms used. Table I results. Algorithm time taken result, cost t, time compel exit y advantage disadvantage. Genetic algorithm 77.041 1355.00, kmn, best possible solution is generated, no optimal solution is reached. Dynamic programming 0.2513 1355.00, n2*2n, generates an optimal solution, easy to code, expensive for memory as well as time. Quality of solution depends on the code. Fig 5. Time taken by GA and DP approaches with various amount of data. The accompanying chart shows that with less amount of data dynamic programming give a lot quicker outcome than the hereditary calculation for tackling traveling salesman problem. However, as the size of information begins to expand, the time taken by powerful programming builds exponentially when contrasted with that of genetic calculation. The exhibitions of the two calculations are unequivocally influenced by their parameters just as their applications. GA is skilled at looking for ideal arrangements in low-input cases. Now and again, for example, with various input greater than 100, the presentation of GA is better than that of DP. In any case, for a lower amount of data, GA takes additional time than DP. DP has a decent presentation in acquiring steady and top-notch solutions, even in looking through huge search space. Be that as it may, because of its exhaustive enumerating nature, it costs an abundance of time in a huge amount of data cases. As of late, Turing has become the significant wellspring of salary for the music industry. Arena visits the executives framework makes the logistics part of Turing simpler and increasingly practical. It will decrease any utilization of paper in keeping up information about visits. V. Conclusion. In sum up, this research contains a function for generating the shortest path spanning all the cities. This will help in covering all cities in a much smaller total distance. Anyway, this venture doesn't mull over a few things like the different levies forced while traveling interstate or the accessibility of arenas on required dates, and so on. With everything taken into account, whole undertaking may come convenient for Turing chiefs. Tools used. The project is implemented using Python 3 and Sclite 3 packages for the database.